So the goal here is that after you have gone through the basic concepts, the goal is to look through these programs, and what I'm going to do is I'm going to run these programs. So you can see the code and also see the implementation, right? And there are some explanations because multi-threading in Java is, threads are somewhat non-deterministic because we talked about the different states of thread, and when you start a thread is not necessarily when it starts running. Running happens at the time of a process getting scheduled by the scheduler and a callback to initiate the run method, right? So I also spoke about the lack of reliability on priorities and certain things, the order of execution, and I'm hopeful that through today's demonstration, the light bulbs will come on. That is not to just say that, well, you know, we've talked about the topics and slides and therefore we're done. These examples should make meaning. So, okay, so enough selling. Let's get to so here is threadx.java, and I'm basically going to create these on the fly, and I'm hoping they'll all compile and run. So you can see the code on the left side. Oh, great. That's not good. Let me fix that. Okay, now that the path is fixed, any questions on this? Pretty clear, right? You can't prioritize using Java threads. So this particular program is just showing you some more threading API. Like, what does thread.currentThread return? This is a static function call that returns the active thread. How do you set a priority? How can you find an active number of threads that are running in your system? Main and garbage collector will show up here. And we can also go in and create a thread array, and we can look at the number of active threads that we found, and we can enumerate those so we can see which threads are running. And we can also call thread.dumpStack. So that way we can, by calling dumpStack, get access to all the elements that are active on the stack for a given thread. So this is more, here let's get to know the API, okay? So if you look at the output, current thread is my thread. That was the name that was set, right? current active thread is 1. The main thread. And it prints that and the stack trace for main. Okay? In your exception handling, you may end up using this. Okay, so I'm interested in showing you usage of synchronize with a, so here is a queue class. You guys will be using this in your 4th assignment for sure. Synchronization with multiple threads. So I've got a queue object with an integer, and I have a get and a post. I have a get and a put. And with each, I'm going to sleep for 30 seconds, 30 microseconds, excuse me. So I'm trying to call the get method and read the value of n. And after that, I sleep for 30, and then I return that value I return the value, basically. Put is trying to set a new value to n. And you can see it does write to the instance variable and prints and goes to sleep. Right? So far, so good? Does everyone understand queue? It's an instance variable with a get and a put. And it's synchronized, which means what? Exclusive access, separate monitor. We talked about all the monitor stuff last time. I read the value, and when I'm reading the value and sleeping for a short time, all of that is synchronized. Meaning even while I'm sleeping, no other thread can touch the queue object, because an lock is set at the queue object level, right? So queue is going to become a shared object with consumer and producer. Consumer implements runnable. It creates a thread and starts itself. And in the run method, consumer is just calling the get method iteratively, forever. Yes? You guys see that? Consumer sets up a thread and starts. And the run method, when you call start, obviously you call this run method, and he's just reading the value constantly. I want to read, I want to get, I want to get. And producer is I want to write, I want to write, I want to write. Same concept, right? And the thing is that producer is writing a new value every time. Okay? So we've got queue, the shared object. We've got the producer. We've got the consumer. And we create our queue. We create our queue. We create the producer and consumer. And basically what we expect is when producer writes a new value, the consumer should get. Yes? Simple enough? Okay. So compile the code and run it. That's happening too fast. But I killed it for a good reason. And you can see whenever a thread gets scheduled, now the scheduler is doing its magic. So the consumer thread read the value 3 times. The producer wrote the value, and the consumer got scheduled for too many times, right? It read the value. So producer writes 2, the consumer didn't get a chance to consume. But when consumer got a chance, so you see there is no rhythm here. It's kind of random. You can see the scheduler at play, right? So how can we set up so a producer can produce once and a consumer can consume once? You use wait and notify. So you only have 2 threads in play right now, right? So you use wait and notify. Now how does that work? Let's look at that example. And I actually, for the sake of understanding, I was thinking of consumer as the person drinking coffee and producer as the person pouring the coffee in the coffee cup, right? And if all the coffee cup has is one sip, right, as an assumption, I'm hoping that when the coffee is poured only, then it's consumed. When there's no coffee, I should not be calling, the consumer should not be working. And so what we can do is, by virtue of wait and notify, consumer can rely on the producer. If there is nothing to consume, the consumer waits on the producer. If there is nothing to consume, the consumer waits on the producer, and vice versa. If the coffee has not been consumed, meaning the value has not been read, the producer should not write a new value, should not pour coffee, right? So I'm going to show you such a goofy program. Let me set it up. Okay, so I'm ready with my program, right? So I have the same class, but now to talk about coffee consumption and producer, I've got the coffee with contents. Just refabricating the same program, right? So while available is equal to false, and please note that content will get a value and available has to be declared right there. It is declared. Okay? Available is false, meaning when coffee is instantiated, the cup is empty. It's that simulation. So now if available is false, there is obviously nothing to get. There's no coffee. So let's wait. We call the wait method in a synchronized block. So wait will basically put the get method, or it will put the consumer in a wait state first time around. When that happens, there should be a put that will take some action. So what does the put do? It says while available is equal to true wait. Well, available is false, right? It's in the same class. Available is set to false. If the get method runs, it's going to put the consumer thread into a wait state. So if a producer runs, it will set the content to the value, meaning it's going to pour coffee in the coffee cup. Then it will say available is true. There is coffee for you to drink. And then it does a notify all. It's sending a message to the consumer, there is coffee for you to drink. That's what notify all does, right? So then the consumer comes out of the wait state. And it says available is false. And does it notify all? It's letting the producer know I've consumed, and it returns the contents. Understand wait and notify implementation? There's a certain way of doing this. And this is the example. Now, how does coffee get consumed? Sorry. So we have the producer goofy and the consumer goofy. Consumer goofy declares a coffee object, right, in the constructor, and it calls the get method. This is only doing it once. And producer also gets the coffee and it puts in 10 and says what it produced. So it's just pouring the value 10, right? So here we go. We create a coffee object. We start it, and then we start the coffee object. We create the coffee object. We first set up a consumer, and then we set up the producer. Now you can obviously refactor this to run in a loop, so you can put in a different value every time, right? That modification can be made. But just to show you guys this, even though I instantiated even though I instantiated consumer first, right? It started, and if I add the print lines, you will very quickly see that it went into a wait state. And then, it slept, the main slept for 2 seconds, allowing the producer goofy thread to add the value, right? And this guy did that. But then it went back to the consumer. It woke up the consumer when A2 was done, and he said, okay, I got 10. Right? Wait and notify working in harmony. You guys will be using this implementation for the fourth assignment. And I'll talk about that later tonight, because you need to know. So this next program that I'm trying to show you, what I want to do is show you the usage of join. How to set up thread interdependency. So let me just run the program and let you guys see it for yourself. And then I'll look at the code. If you wanted some control on multiple threads working together, so how does that happen? It's by using the join method. What is the purpose of join? The idea is that if 3 threads are created in main, as you see OB1, 2, and 3, it is, and the join method is called, then main will simply wait for those 3 threads to finish before it will carry on forward. Okay? So this part of the code becomes a blocking call, which basically means that at this point in time, meaning the highlighted code, I'm going to wait until OB1, 2, and 3 are done. And then finally, I will print out the rest. If I take this out, it's likely that main will not wait for other threads. Am I making sense? Right? And that's really what happened here. There is no order to the thread creation. We still see that little bit of unpredictability that we get with this from the scheduler. And finally, it gets to the main says, okay, I'm waiting for threads to finish, so I'm pausing after all this different interaction. And then the threads finish, and there is really no reason for these to print, they're still somewhat in random order, as you can see. But at least the point is that main is in a wait state, waiting for OB1, 2, and 3 to finish. When the 3 threads exit, and this is, like I said, a blocking call. There is no sleep here. We'll wait as long as OB1, 2, or 3 are not done. So it's like when a main thread joins another thread, what's happening? It's just now waiting for that thread to die so it can carry on forward. That's basically what the API says. What is join? Waiting for a thread to die. If you just read the API description, it doesn't make any sense. But an implementation probably helps. Yes? Clear enough? Okay. So here is an example that shows you how to synchronize a shared resource. So let me just run this. See the output? The entire array of strings is implemented in a way that it can complete its sentence without T2 interrupting it, right? So we can even implement something so people can talk over each other, and I'll show you that. How is that done? Well, how does this work? So first of all, let's see what's going on. We've got a static string, and we've got two threads, and we start both of them, right? I could have very easily just used join instead of writing this block of code. But this shows you how join works internally a little bit. So we have got two Boolean threads, T1 and T2. We've got two Boolean variables, T1 and T2 is alive. And we basically say, since we have started the two threads, we basically say, we set those to true. Then we have a do while, and we say until T1 is alive or T2 is alive, I'm just going to stay in this loop. Now, how does the value of T1 is alive or T2 is alive change? I say if T1 is alive, meaning if I know that T1 is still alive and not of T1 dot is alive. This is an instance method that makes a system call, and it says when T1 becomes dead, it's going to return false, right? So I know right now the thread is alive, and if I find out from the system it's dead, I will declare it dead. Yeah, and same here. So this program is doing two things. One, it's showing you how join works, and it's also showing you how to share a resource. We haven't talked about that. So same story for T1 is alive. I say, I know I'm alive, and if I learn from the system that T2 is dead, then it's dead. Okay? So then I have this random wait to print out stuff, and then notice what happens in the bottom. Synchronize system.out. System.out is synchronized, guys. And when this is synchronized, we're going into the for loop and printing out in the run method, right? I could get rid of this. Now watch what happens. This is an example of people talking over each other, right? Happens in meetings all the time. Well, sometimes, when, for whatever reason. Let's not go there. That's nothing related to Java. But to bring order to the chaos, this is better to do in Java. Why? You're taking a lock on one object. When you write a synchronized method, right, that's a much bigger deal, because there, when you're basically locking the object in which the synchronized method is. You're synchronizing. You're locking the object, and hopefully for a longer duration, because synchronized methods should be very small atomic operations. There shouldn't be a lot of stuff inside. Okay? Question. So these are all the examples of multi-threading that I wanted to show you. I'm ready for, I should let you guys take a little breather.